This is lesson 9.3, Multiplying Binomials. We're just going to go ahead and skip example 1 since that's a method you'll probably never use. So moving on to example 2, they want us to simplify 2y minus 3 times y plus 2. Well, we can see obviously we're trying to multiply two binomials together. In order to do that, what we really need to do is distribute every term, or each term, in each one of these parentheses to each other term in the other set of parentheses. Now that sounds kind of confusing, and it would be if someone hadn't come up with the term FOIL. And that's what we're going to be doing. FOIL stands for first, outer, inner, and last. That means we're going to start by doing the first term, then the outer terms, then the inner terms, and finally the last term. So let's see if we can implement that. We're using the distributive property as we do that. So I'm going to multiply the first term in this set of parentheses times the first term in this set of the parentheses. That'll take care of our f, the first. First times the first. 2y times y is 2y squared. And that's because y times y is y squared, and we have that 2 there. Then we have our outer is next, so I'll multiply the outer terms. They're on the outside of our parentheses, so we have 2y times 2. 2y times 2 is 4y, so it's plus 4y. So we're taking care of our first and our outer. Then we need to do our inner. Our inner, negative 3 and y, there are inside terms. Notice that they're inside relative to 2y and 2, which are outside. So we have negative 3 times y, which is negative 3y. And finally, we have our last terms, which would be negative 3 and 2. They're both the last in each set of their parentheses. Negative 3 times 2. Negative 3 times 2, negative 6. As you can see, we have successfully multiplied 2y times everything in this set of parentheses and negative 3 times each term in this set of parentheses. So everything's been multiplied together, and we have satisfied what they've asked us to do. However, we're not done yet because they told us to simplify. So if we can, we need to simplify this polynomial. And I see two like terms, so we need to combine these two like terms. 4y minus 3y gives me y, so I have 2y squared plus 4y minus 3y. Again, that's plus y minus 6. Now I can't do anything else. There are no more like terms to combine, so I am finished. I have simplified. I know that probably seems a little confusing, so let's do another example together. We're going to do the same thing. We're going to simplify 4x plus 2 times the quantity 3x minus 6. And again, we're going to use FOIL. First, outer, inner, and last. So we'll start with our first. First in this set of parentheses times first in this set of parentheses. First times first. 4x times 3x. 4 times 3 is 12. X times x is x squared. Then we have our outer. 4x and negative 6 are on the outside. So 4x times negative 6 is negative 24x. Then we have the inner, so we want the two inside terms that are on the inside of our two sets of parentheses. We have 2 times 3x, which is plus 6x. Finally, we have our last terms, 2 times negative 6. They're both the last in their each respective set of parentheses. 2 times negative 6 is negative 12. Now that we've successfully multiplied our two binomials together, we need to make sure that if we can simplify, that we simplify. And again, I see we do have some like terms that we can combine, so we need to combine our like terms so that we fulfill the simplification direction. So I have 12x squared, negative 24x plus 6x. Now I end up with a negative 18x minus 12. And that is now in simplest form, so we are finished. Great. Let's try a quick check on your own. we're going to do quick check 2D. I want you to simplify each product using FOIL. It's the same thing we just did. We're going to be using FOIL again. First, and then the outer, the inner, and the last. So we have first 3x times 2x. 3x times 2x is 6x squared. Then I have our outer, which is 3x times negative 5. Outer times the outer. 3x times negative 5 is negative 15x. Then we have our inner. Inner times the inner, negative 4 times 2x, negative 8x. And finally the last. Last times the last, negative 4 times negative 5. I end up with a positive 20. Again, we need to see if we can simplify. We have some like terms, so we need to make sure that we combine them. Negative 15x and negative 8x. So I'll bring down my 6x squared. Negative 15x minus 8x, so it's a negative and a negative. I end up with negative 23x plus 20. All right, let's go ahead and move on to example 3. In example 3, we want to find the area of the shaded region. Now, I know this looks pretty complicated, but it's really not. What we're going to do first is let's make a plan. So if I was to solve this, I want to just find the blue area. So I'm thinking, well, if I found the area of this large rectangle, and then I subtracted out the area of this small rectangle, I'd end up with the area of the shaded region. So that's my plan. I'm going to find the area of the large rectangle, then I'll subtract the area of the small rectangle from that, and that'll leave me with the area of the shaded region. All right, each one of these shapes are rectangles, so we need to know how to find the area of a rectangle. To find the area of a rectangle, our formula is length times width. So let's use that formula and let's find our areas. I'll start with finding the area of the large rectangle, which is length times width. The length is 3x plus 2 times the width, which is 2x minus 1. Now this should look very familiar since we just did something exactly like that. So we're going to do exactly what we've been doing, which is FOILing. We'll start with our first, outer, inner, and last. So we'll do our first times our first, 3x times 2x, which is 6x squared. Then we have our outer, 3x times negative 1, which is negative 3x. Then we have our inner, 2 times 2x, which is a positive 4x. And finally, the last term, 2 times negative 1, which is negative 2. Again, like we've been doing the whole time, we need to see if we can simplify, and we can. Negative 3x plus 4x, so I end up with 6x squared minus 3x plus 4x is plus x minus 2. Can't do anything else to that, so that is the area of our large rectangle. Now we need to find the area of our small rectangle. We're going to do the same thing, length times width. So I have length x plus 3 times width x. Since we're multiplying, I can switch these around, and to me it's easier if I put my x first times x plus 3. Now we should know how to do this from our previous lesson. All we need to do here is just distribute. X times x, x squared, and then x times 3 plus 3x. We can't simplify, so that is the area of our small rectangle. Now to find the area of the shaded region, all we have to do is subtract these two. So if I'm going to find the area of the shaded region, I want to take the area of my large rectangle, 6x squared plus x minus 2, and from that I'm going to subtract the area of my small rectangle, which is x squared plus 3x. Just barely squeeze that in there. Okay, so from the last lesson, or from lesson 9.1, you should remember that we need to distribute our negative first. So I have 6x squared plus x minus 2. Then I'll distribute that negative, so I get negative x squared and negative 3x. And now I can simply combine like terms. I'll start with my x squared terms. I have 6x squared and negative x squared, so I end up with 6x squared minus x squared, 5x squared. And then next I'll do in decreasing order, remember, because of standard form. Next I'll do my x term, so I have plus x and negative 3x. X minus 3x is negative 2x. And finally we have our negative 2 minus 2. And that right there is the area of our shaded region. We can't simplify it, so we are finished. Let's do one more of those. We'll do quick check 3a. Again, it works the exact same way. To find the area of the shaded region, you're going to find the area of the large rectangle minus the area of the small rectangle, and you end up with the area of the shaded region. So I'll start by finding the area of the large rectangle. And again, we'll do length times width. So I have 5x plus 8 times 6x plus 2. I just took these two and multiplied them together. We're still using FOIL, first, outer, inner, last, to multiply our two binomials. By the way, FOIL only works with multiplying two binomials. So I have my first times my first, which is 30x squared. 5 times 6 is 30. X times x is x squared. And then we have our outer, 5x times 2, 5x times 2 plus 10x. And then we'll do our inner, 8 times 6x plus 48x. And finally, we have our last, which is 8 times 2, 16. Again, we need to see if we can simplify. We can. We have these like terms here that we need to combine. So we end up with 30x squared plus 10x plus 48x, 58x plus 16. That's the area of our large rectangle. Now we need to find the area of our small rectangle. Again, length times width, so I have 5x times x plus 6, and all we need to do is distribute. 5x times x, 5x squared, and then 5x times 6 plus, sorry about that, plus 30x. We have no like terms to combine here, so that is the area of our small rectangle. Now again, to find the area of the shaded region, we need to subtract these two amounts. So if I'm going to find the area of the shaded region, then I want to take the area of my large rectangle, 30x squared plus 58x plus 16, and from that I need to subtract the area of my small rectangle, which is 5x squared plus 30x. Again, we need to distribute that negative first, so I end up with 30x squared plus 58x plus 16. Negative times 5x squared, negative 5x squared. Negative times 30x, negative 30x. And I can simply combine like terms. Again, we always start with the highest degree, so x squared is the highest degree. I have a 30x squared minus 5x squared, which leaves me with 25x squared. Then we have our x terms, which would be a positive 58x and a negative 30x. 58 minus 30, positive 28x. And finally, we have our constant term, 16, and it's all by itself, plus 16. And there we have the area of the shaded region. All right, moving right along here, we have our very last example, which is example 4. We need to simplify the product. Now, why don't you see if you can work on that one looking on your book, and while you do that, you can also search for the next video for this lesson because we are out of time.